Alrighty, great. Well, it is 11 a.m., so we'll start on time because we have a lot of information to get through, and I want to make sure that we get through as much as possible while y'all are here. So, welcome to today's newline workshop titled Your First Data Visualization with Svelte and D3. I'm super happy that you're here, whether you're watching live or you're watching after the fact in the recorded version. Really excited to talk a little bit about Svelte and D3 for data visualization, a set of tools that I've used in combination for a little bit now, and I've really fallen in love with that I want to kind of teach others about because Svelte is a relatively new tool and there aren't a lot of resources out there yet for how to use it for data visualization. So as people are trickling in, I think just hit 11 people are coming in. I'll set some expectations, ground rules for today's workshop, kind of what you can expect. The workshop should be around 1 hour. It might be slightly longer depending on how many questions are asked, but definitely at minimum, we'll probably take advantage of this full hour that we have scheduled. The other thing I'd like to talk about is how the workshop is conducted. I've been to too many workshops where the presenter kind of runs through all their material and then they reserve 10 minutes for a question and answer at the very end, and it feels very rushed. And people don't want to ask their questions because their question was from 40 minutes prior and it's no longer relevant at the end of the workshop. I don't want that. What I want is for you all to ask questions as we go, as soon as we encounter an issue. One of the worst feelings is whenever you fall behind in something like a workshop, you don't ask your question, and then that hole just gets deeper and deeper and deeper, and you become more and more increasingly confused. Let's avoid that by asking questions whenever we have them so that we make sure that we're all on the same page and we proceed together. Okay. Great. So with those kind of ground rules in place, I see a lot of people in the chat saying hello. Awesome to have so many of you all here. Thanks for being here. Thanks for saying hello. And let's go ahead and get started. What I will do is I will switch my stream to be this presentation mode. And so you should see now my screen. And what I'm going to do is I'm going to share a link with y'all that you can follow along with. And I'll put this in the chat right now. And if you click this link, you should be able to follow along directly with what I'm presenting as I'm presenting it. So this is kind of an informal presentation. These aren't really slides. It's just to orient where we're at during today's workshop. So feel free to follow along using this as we kind of go through today's workshop. So this is, as we've said, your first data visualization with Svelte and D3. This workshop is kind of a preview of the types of work that I've been putting together for my upcoming course titled Better Data Visualizations with Svelte that I'm producing with Newline. So if you like what we do today, definitely check out this course whenever it formally launches. There will be 4 or 5 charts that are much more complex than the one we're producing today. So I hope that this is really helpful for y'all as well if you enjoy what we go through today. Somebody said they don't see the link, so I should be able to copy this link and share it in the chat. Robert, if you can't access this, let me know. But otherwise, it's not super important that you follow along with your link. If you can just see my screen, that should be sufficient as well. So let's go ahead and get started with kind of the agenda for today. We'll start off with who you are, the attendee, not in a meta way, but just in what we kind of expect for the ideal student who's going to get the most out of this. Second, we'll talk about who I am and why I am qualified to speak on this type of topic. Then we'll talk about why Svelte is uniquely well suited to data visualization, and then we'll finally build. And since I know the majority of you are here for that last step, that's where we'll spend the majority of today's workshop. Probably 40 to 50 minutes will just be on building a scatter plot together. So now that we have the agenda down, we can go ahead and talk about who you are. Ideally, this course is well suited for 2 types of people. One are people interested in Svelte or data visualization. You're going to learn about Svelte because that's how we're producing the charts, and you're going to learn about data visualization and some of the components that go into that as well. So this is well suited for both of those types of people. The second quality that we'd like for students is beginner proficiency, ideally in either HTML, CSS, JavaScript, and or SVG. I recognize that's a long list, and so there might be some issues with knowing all of it, but whatever familiarity you do have with these kind of web tools will be helpful as we get started. It's not a requirement, but it probably will help as we get into the weeds for our first chart. And Robert, I see you just said that my stuff isn't making it to the chat. Maybe it's just not being sent because it's a link and YouTube is trying to block it. I'll send it to the Newline team and hopefully they'll be able to send it as well. But if and when it doesn't make it, it's no big deal. You can just follow along here. So sorry about that inconvenience if it ends up not making it to the chat. So that's the ideal student. Now let's talk a little bit about who I am. So my name is Connor and I make charts for a living. My website kind of is the best introduction to me. You can see it at connorrothchild.com. But I've worked on a lot of projects with Svelte and D3 in particular, ranging from projects about Bob Ross's art to Kid Cudi and how much he hums in his music, and then more serious topics like how often migrants go missing over the last few years. So a range of topics, but the common thread is that most of these are in fact using Svelte. So I love Svelte for data visualization, and you can kind of see this in action in my blog. So I've written about this a few times, and the best article I think that introduces this is titled "Making Visualizations Literally with Svelte and D3." So this is the blog post, and this is kind of transitioning into the why Svelte version or part of this workshop. Specifically, I want to give this overview of kind of modern history of data visualization, starting off with imperative ways of programming charts that would be a pain for all of us, and then D3, which came along a few years later, which made life a lot easier, and then Svelte, which is the new kid on the block, and why I think that is going to define the new paradigm for data visualization in the near future. So what you'll find in this post, I'll kind of just summarize it quickly, is this example of trying to bind data to the radius of 5 circle elements, right? 1, 2, 3, 4, 5. And you'll see here that the data is 5, 10, 15, 20, 25. And the way that this is done in imperative programming, maybe the old way before D3 existed, would be something like this chunk of code. As you can see, it's very long, and it doesn't really matter what's happening here because you'll never do this, hopefully. But basically, there's a data array. You're grabbing all the circles on the page, you're looping through them one by one, and you're setting the radius property. So that's a very long, lengthy, verbose way to bind data to circle elements using imperative vanilla JavaScript. So D3 came along maybe 10 years ago and basically simplified this process a lot. It removed the need for a for loop and it iterated on your selection of data for you. So in the D3 way, you would simply select all the circles, bind the data directly, and then provide the radius attribute with this one-liner. So we reduce the length of code by a factor of 5. It looks a lot nicer. And at the end of the day, these two examples are doing the exact same thing, right? They are creating an SVG element, which we can see in our dev tools here. And then they are binding the radius to 5 different circles. You can see that directly here if you look closely. Radius is 25, radius is 20, radius is 15. So that's great, and D3 did make things simpler. But what if we could simply write this SVG that we're already seeing in our markup? If we could just write that directly, or as I say in the blog post, write that literally. And instead of having this complicated selection method and this chaining and learning D3 syntax from the ground up, instead of doing that, we just wrote the markup that we want to see directly in our code. And that's exactly what Svelte allows us to do. If you scroll down, you can see a good example of this in action, where if we have an array of objects that represents our data, we can actually write the SVG markup that we just saw in our browser and simply bind our data to the CX, the CY, the radius directly. And so this is a big paradigm shift in how we're designing data visualizations, because in both the imperative vanilla JavaScript and in the D3 selection method, we are providing instructions to the browser, right? That is the key difference. We're providing instructions to some JavaScript behind the scenes, we're letting it do its magic, and then it is rendering 5 circles and binding data to them. With Svelte, we don't have to provide instructions at all. We simply write what we want to see, and what we write is what we render. And so it's this huge paradigm shift in how we're designing data visualizations, and what I and many other data visualization practitioners think is simply way more intuitive, way more natural, and doesn't require you to learn the syntax of a whole new language like D3 from the ground up. So I think this type of paradigm shift is why so many newsrooms and so many data visualization studios are beginning their transition to Svelte as kind of their de facto tool for data visualizations in the modern day. It's a massive trend that's happening, and I think this is the primary reason why. So that is why Svelte is being used for data visualization. I hope this example kind of illustrates some of the logic as to why Svelte is powerful. And now that we know why Svelte is uniquely well suited to data visualizations, we can talk about what we'll be building with Svelte. So this is the example for today's workshop. It's in a code sandbox that'll load now. And as you can see, it's a pretty simple chart, okay? This is fake data. I'm just using my friends' names and adding some fake data points to them, but it's meant to illustrate the relationship between hours studied for an exam and final grade on that exam. And unsurprisingly, you see this positive correlation where people who study fewer hours end up scoring worse on the exam, and people who study more for the exam end up scoring higher. This is unsurprising. This is what we would expect. And what I want to highlight about this chart is that it is not groundbreaking, right? This is a simple scatter plot that we can create in 45 minutes together. It is not meant to win any data visualization awards. It is not the craziest chart you've ever seen, but what it does have is the patterns that you will need to design any data visualization in Svelte moving forward. So what are those patterns, right? What are those features that we want to highlight here that you can use in future charts? First would be peripheral elements. So you'll notice these subtle axis labels, axis ticks, and axis titles that exist surrounding our chart. Second would be responsiveness. If I make this chart smaller or larger, you'll notice it will adapt to the screen size that it occupies, meaning that this could be viewed on a huge desktop, on a vertical phone, or on a small screen. And third and finally is interactivity. So if I hover over a point, we see a tooltip. If I move to a point, we see a nice transition. And if I hover off the chart, that tooltip disappears. So again, we're not trying to create a crazy full-featured storytelling chart. We're simply trying to create a chart that enables us to focus on the patterns that are accessible for charts in the future as well. So that's what we'll be building today, is this scatter plot. And if you want to follow along, the way that you can do so is this code sandbox template that I have linked within the slide deck. I see a lot of you are now following along, so you should be able to access this. But if you can't, I can drop that link again. So a direct link to this template. I'll send this to the newline team, and they'll be able to drop it there. But this is the beginner template that we'll start with. And as you can see right now, it doesn't have any visual elements. It just says, let's make a chart. So what you're going to want to do once you pull this up, assuming nobody has any setup issues, assuming you can open this, you may need to create an account. Hopefully that doesn't take too much time. But if you'd like to follow along, you'll click this fork button in the top right corner of your screen. What you'll then notice is the title of this sandbox will change to some random string of characters that doesn't actually mean anything, and then the sandbox will reinstantiate like this. So I'll give everybody a few seconds to kind of set up and fork their sandboxes that we can all code along together, with the note that following along is optional. So I've been to workshops where I enjoy following along because I want to code next to the person. I've also been to workshops where I don't fully know how to follow along because I just don't speak the language. So if you just want to immerse yourself and see this being created rather than create it yourself, you definitely don't have to code alongside me. But if you want to, this code sandbox is how you'll do so. So I'm getting an error, so I'll just fork it again. Sometimes code sandbox can be finicky. So if you run into an issue with the setup, it might be so many people forking it at once. You can just fork it again or maybe hard refresh your browser. That should fix it. So So I'll give everybody some time to set that up. There we go. So I forked it again and now it works. So if you have a weird setup issue, just refork and that should fix your issue. But while people are doing that, I'll give a brief overview as to what's in this application. Okay, so we'll start off in app.svelte, and this is the primary file that we'll be working in today. As you can see here, we're eventually going to delete all of the contents in app.svelte, but before we do that, I'll give a brief overview of what you can find in any Svelte file that you create. So there's three things I want to highlight: the script tag, the HTML markup, and the style tag. So these are the three components that are present in any Svelte file, including this primary app.svelte that we're working in now. So starting off with our script tag, we see there are a couple things happening here. First, we're importing a component called example from this path, components/example.svelte. And second, we're importing data from data.js. You notice that components exist here and data exists here, and that we're importing these objects, these files, into our app.svelte. The second thing you'll notice is that we're console.logging this thing called data that we already imported. So if you go down here in the bottom right corner of your screen, you'll see your console active. And here you can see that the console log is in fact working, and that we see an array of 18 objects, each representing a student in our dataset. So what you're deducing here is that the script tag is where the logic of our application lives. I could console log something else like 2 + 2 and save that, and it would console log the number 4. Maybe, I don't know why it's not hard reloading. Yeah, there it is, 4. So you would see that it does in fact console log 4, or you could do anything else. You could do a string, and you would see that update as well. So that is where the logic in our app lives, is in the script tag. The second thing we want to highlight is this HTML markup. So HTML is basically the content of our page. And that's made very obvious whenever you look at let's make a chart present on the left side of our screen, and let's make a chart present on the right side of our screen, right? This is a direct one-to-one relationship between our code and our content. You write your markup in your tag right here, and it appears in your web page. So that's pretty simple. And the third thing is styles. So without styles, this whole web page would look very ugly. It would basically look like this, which is horrendous, and we don't want that. Which is why we use CSS styles in the style tag to change the appearance of our markup. So as a 10-second overview, script tag includes logic, markup includes content, style tag includes styling. I hope that introduction to Svelte on a very high level is helpful, and it will kind of orient as we get into today's workshop. So I'm going to do what the workshop template says to do, which is delete all the contents in app.svelte. And then I'm going to click save. Immediately you will see everything disappears and the console is freaking out because nothing exists. We'll fix that in a second. But first, let's define exactly what we want to do inside of our chart. And specifically, we can kind of break today's workshop into 4 discrete steps. And these steps are actually pretty replicable across any chart once you start to understand the patterns at play. So the first thing we'll do is draw circles, because you can't have a scatter plot without points. The second thing we'll do is add peripheral elements like axes, tick labels, and axis titles. Third, we'll make it responsive so that it's accessible on any screen size. And fourth, we'll add interactivity via tooltips so that you can always see information on hover. So with those 4 steps in mind, the first thing that we're going to do is draw circles. And in order to do that, we need to create an SVG element and place circles inside. So again, you might have varying levels of exposure and experience with the web, including SVG, and you may not know what SVG is at all. So if you visit this link for SVG documentation, you can start to better understand what we're going to be working with. So an SVG element is a container of sorts, and inside of that SVG container, you have elements that live within. For example, these 2 circles right here. And by writing, the SVG container and then the constituent elements inside, you get things that look like this. For example, 3 circles that live within one big SVG. And if I go ahead and inspect the code for these, you'll see that, like we talked about earlier, this is exactly the attributes that we wanted to render: cx of 50, cy of 50, and r of 40. And you can see that directly in the markup for this web page. So basically, we're creating visual elements and we're writing them using SVG. That is the simplest introduction to SVG that you can get. Of note with SVG, it stands for Scalable Vector Graphics. And what that means practically is no matter how far in you zoom, you're going to have the same level of quality, which is one big perk of using SVG for data visualization, is it's always going to look crisp and it's always going to look nice. It's never going to be pixelated. So that is SVG, and for our first example of drawing circles, for the first step, we can just create an SVG and save it. And immediately you'll see this resembles exactly the example that we saw in the web docs, unsurprisingly, because that is what we copied exactly. And let's go ahead and clean it up by removing some of the things we don't need, which we'll re-add later. So I'm just going to create an SVG with two circles. A big circle and a small circle. The big circle has a radius of 40. The small circle has a radius of 4. If I increase this radius and clicked save, you would see two circles that look identical. If it had a radius of 0, it would disappear. This is unsurprising. This is what we expect. And if you want to learn more about the circle element in particular, you can visit the circle reference right here, which gives an overview of the attributes that you need for your SVG elements, like CX, which is the X position, CY, which is the Y position, radius, and then others like fill, stroke, color. There are a lot of attributes that you could apply, but the main ones that we're going to focus on are CX, CY, and radius. So let's go back here and describe exactly what we want. And let's start off with just one circle. Rather than just this circle, we want to have one circle for each student within our data set. Recall that this data has 18 students within it, and we want one circle for each of them. The first thing that we'll need to do to achieve this is to import our data from this data file. So the simplest way that we can do that is by writing import data from, and then find the path that the data lives at. So if I'm in app.svelte, I need to go to the data folder and then find the data.js file. So I'll do dot period to say the current folder, find the data folder, and look for data.js. Now you'll see there's no errors, which means we probably did something right, but to verify that we did in fact do this correctly, we can console log data and click save. And here you see exactly what we wanted to see. Each of the data, each of the students, each in their own object in this array. So now the question is, how do we get this array of 18 objects and render it within our markup? So instead of SVG with a single circle, we have 18 circles, each representing a student. The way that we'll do that is with a Svelte each block. And you can go ahead and Google this if you want, or you can just see my screen. But basically an each block iterates through an array, for example here between these cats objects, and it renders each of the elements within in some markup. So that might sound kind of confusing. It's probably easier if we just write it together. So if we want to render each data point, we can do pound each data as student, because what we're essentially doing is rendering each data point, each person in the data, as student. Or this could be named anything else. It could be named item, it could be named D. This doesn't matter. This is just whatever label you want for the individual. Then let's end the each tag after the circle. Now, right now you can only see one circle because they're all stacked on top of one another. But if you actually inspect element, what you'll notice is there are in fact 18 circles, right? 1, 2, 3, I'm not going to count all 18, but you notice that this each loop is in fact working and rendering multiple circles on our web page. But we don't want each of these to be at their own position. We want them to be positioned according to the data. So if you look at each object, you'll notice that there is a name, which is a text string, an hours value, which is a number, and a grade value, which is also a number. So what we want to do, if you remember from our original chart over here, is we want the x-axis to be final grade and the y-axis to be hours studied. So let's just write that directly within our code. So instead of CX being 50, we want CX to be the student number of hours. Or actually, we want it to be student grade. And then we want for the CY for that to be the number of hours. So what I'm doing here is I'm getting the object property, like hours or like grade, and I'm rendering them by doing dot and then the name of that property. So now if I save this, you'll notice they're all overlapping because the radius is too large. I'll change it from 40 to 4 and click save, and you'll start to see our circles appear where we would expect them. It looks like somebody in chat said they're getting sandbox errors. Code Sandbox has been finicky lately. I think your best bet is probably to just fork your current sandbox that's having errors, assuming it's saying like 502 error. Just fork it again and see if that works. Otherwise, I can try to troubleshoot with you after the workshop one-on-one. So sorry about that sandbox error if in fact it doesn't get resolved. So what you can see here is the set of circles, and the trend is actually upside down, which we'll get into later, but you can start to see the shape of our chart taking form. Now, obviously the main issue here is that these values are fixed to the data that's currently present in our object. So whenever we write student grade and student hours, we're rendering them between 44, between 50, between 60, between 99, and we're not taking advantage of the full potential SVG width, right? What we actually want to do is take these raw values and map them to scaled values. And to do that, we want to scale circles according to chart dimensions, and we'll want to use D3 scales. So here's some documentation for the most simple D3 scale called scale linear, which basically takes in a domain of two potential kind of extents of an array. And once you pass a number into that domain, it will return a number between the range. I think that might have been a confusing explanation. So here's a visual illustration of it. Say we had a domain of 0 to 1,000. An input of 500, because that is halfway in between 0 and 1,000, would output a number halfway between the range. So if the range were 0 to 400, it would result in an output of 200. So I think this visual explanation kind of explains better what we want to do. If we passed in a value of 0, because that is the lowest point in the domain, it would also result in a 0 on the range. And passing in 1,000 would result in a 400 in the range. So that's what we want to do, is we want to scale our values according to some range that represents real chart dimensions. So to do that, let's go ahead and add a width of 400 and a height of 400 to our chart. So we have width and height, which are variables in our markup, and we can go ahead and assign those to our SVG element like so. So now if I save this and I go into my inspect element and hover over this, you see the SVG is a 400 by 400 square, right? So our SVG is in fact responding to the dimensions that we provided from our script tag. And actually, fun fact for you, if you're new to Svelte, because these two are named the same, height and height, we can go ahead and just delete this. Same with width, and click save. You'll see the exact same thing occurs, right? So because the name is the same as its value, we can just render in curly braces. So now we have an SVG that is 400 by 400, but our CX and CY values are still raw points. What we want to do is scale them using scale linear, which is exactly what we were showing earlier. So let's go ahead. You don't have to copy this, you can write it directly, but we'll create a scale linear and we'll call it X scale. And this domain, remember that our X values are the grades of the students. Our domain will be 0 to 100, because at least on the exams that I've taken, that is the possible range of values you can get for an exam, right? Your grade is either 0%, 100%, or somewhere in between. So that is our domain. Our range, meaning the values that we want to output, is not 0 to 600, but 0 to width. And right now, width is 400, so that would in fact be the range. Now I'm gonna click save, and you're gonna notice there's this bug. It's not gonna be descriptive in Code Sandbox, but if I go into my browser, you'll see scale linear is not defined. And the reason for that is because scale linear exists from a dependency, from a module that we need to import called D3 scale. So what we'll do here is we'll go ahead and type import scale linear from D3 scale. Now this whole world of importing and NPM modules might be kind of confusing. For now, I'll just show you how to import the important dependencies that you'll need in most charting projects, like scale linear from D3 scale. I'll click save, and now you'll see that that bug disappears, but our values are still not scaled. That's because we created X scale, but we haven't used it yet, right? So let's take these raw X values, student.grade, and let's just pass the X scale into them and click save. Now you already start to see that the elements are spanning the entire chart. They are spanning the entire width, which is exactly what we would hope for. Let's just do the same thing for our Y value. So we'll just copy this for now, and we'll say const Y scale equals scale linear. Instead of 0 to 100, you'll notice that within the data array, the greatest number of hours is 60. So we could write 60 here. A technically better practice would be to find the array max using this function called max from D3 array. And so you don't have to do this, but this is going to result in the same thing, where I find the max of the hours array and I click save. And now you'll notice that it didn't change anything, meaning we didn't break anything. So let's use this Y scale and let's scale our student.hours. And just for readability's sake, I'll put these on their own line and click save. Now you notice that our chart is taking up the entire 400 by 400 dimension. It's exactly what we wanted. Now those who are paying close attention might notice there's a big issue, which is that the chart is upside down, right? Oh, and this should be height, sorry. The chart is upside down. That is obviously an issue. If you look at our real chart here, you'll see that the numbers go up, not down, and that is the relationship we would expect whenever we're talking about charts. The reason for this is kind of complicated, but basically SVG elements start in this top left corner from a 0, 0 position, whereas most charts you're thinking of start at the bottom left with a 0, 0 position, right? So what that means is that our chart is actually flipped if we pass this range of 0 to height into our Y scale. And what we actually need to do is switch these so that height is actually the smallest value in the range, because if it's 0, it should be up here, and if it's the largest value, it should be down there. So if we save this, we'll notice these numbers flip, and we have this correct trend line that we expect. That might be confusing to you, flipping the range from height to 0 instead of 0 to height. It is for most people, and it's something tricky that you'll always encounter. Just remember that if you're going to scale values from the height, you need to flip it upside down. That is going to be true in any scatter plot that you produce using Svelte and D3. Just to make this look a little bit closer to our actual final chart, let's add some additional styling. Let's make the radius 10 and save that. You see it gets bigger. Let's make the fill, which is the color, purple. And then let's add a stroke, which is the color of the outline, black. And now you already start to see these circles are looking almost identical to the circles that we have in our final chart. So that is the first bit that we need to do in order to make a scatter plot, is we need to render circles within the browser. And that's what we've done in this first step. By building an SVG, rendering a series of circles using each, and then scaling them using scale linear. So if anybody has any questions about how to draw circles or any of the things we've went over, I would encourage you to visit these 3 links. But then if that doesn't answer your question, feel free to drop any questions you have in the chat. Meanwhile, we're going to move on to step 2, which is adding peripheral elements. Now first, what do I mean about peripheral elements? I'm talking about these things on the side and in the background of the chart that give reference to the user without being visually obtrusive. So those include these axes labels, the long grid lines that span the entire chart, and the axis title that exists over here. Now the way that we're going to want to render these is using new SVG elements called line and called text. So I think these names are pretty self-explanatory, but line will span from an X to a Y, both X1 and Y1, and X2 and Y2, and create a line. And text will render text, where you can provide an X and a Y value, and you can render that text directly. You could write something ugly like this if you really wanted. We're going to render lines and texts within our axes so that we can actually provide reference to the user. And rather than write all of this code inside of app.svelte, you could imagine that getting very, very long. We're going to leverage what are called components. So if you remember earlier, this example component had its own content, which we then ported into the main page pretty easily. We can actually go ahead and delete this and create a new file in our components and call it axisx.svelte. This will be blank for now, but we can go ahead and add some dummy text so that we can see what's happening. And then I'll place this at like the 50-50 position just so we can see what's happening. Again, it doesn't appear because it's not in our main app yet. But if I import axisx from axisx.svelte, you need to find the correct path, which is components/axisx.svelte. We can then render it like so. So now what you're noticing is that this is existing from here, and it's rendering directly within our SVG. I provided the wrong attributes. This should be x, not cx and cy. And now you'll see hello is in fact visible at that position. So basically, components allow us to take self-contained chunks of code, place them in their own file, and then kind of port them into the main file if and when we want, just with this single line declaration. So we have much shorter code bases. We can access characteristically different chunks of code in their own file. So we don't want the word hello, right? We want a bunch of x-axis ticks that look like this to represent the final grades of students. So let's define exactly what we want, starting off with the logic. We want a series of what we'll call x ticks. And we can generate these programmatically using some math, or we could just say that we want them to be 0, 25, 50, 75, and 100, which I think is a fair assumption. If you'll recall from earlier, we can loop through arrays like so, by writing each and then the name of the array as whatever you want to call it, and then end the each block afterward. So now you'll actually see there are 5 hello text elements right here, because this each block is in fact replicating them. We don't want to print hello, we want to print tick, and you'll notice all these numbers are now overlapping. So that's also not what we want, right? We want these to exist at the bottom of our chart, and we want them to be spaced evenly, as we see in the final chart, to represent the actual values that they represent. So the way that we do that is by pushing them all down according to the height of the chart. And we could just do this and say the y should equal 400 because that's the height from over here. Or we could be more diligent and pass in height as a prop to our component. So essentially we're saying take the variable that exists in app.svelte and give it to axisx as a property. Then you can accept it in axisx like so. This is a kind of confusing syntax, but export let in the name of it will accept it. And then you'll see if I go ahead and console.log height, and then I save it over here, you'll see that 400 does in fact print. So instead of putting 400 here, instead of hard coding that, we should actually add height. And now you'll notice they stay at the bottom where they should be. If I did in fact change the height to something like 200, that would live update, which is the benefit of using this prop rather than hard coding it. So the last thing we want here is we don't want to put these all at the 50 position. We want to put them at their scaled position. So let's do the exact same thing and pass x scale as a property into our axis x. And since these are the same names, we can actually just do this. And then let's go into axis x and accept x scale. Now, because we want to do the exact same thing we were doing through the points, we can simply make the x value the x scale of tick and click save. And already you're seeing these axes labels live where they should be. So that's basically what we want to do. We need a little more polish, which we can get to later. But first, let's just get the broad strokes for the axis y out of the way as well. We'll create a new file called axisy.svelte. And in that, we'll just copy what we had from axis x, and we'll start to switch it up based on what we know about axes, right? So whereas axis x will live on the bottom, axis y will live on the left. and have these reference points over here instead. We also know that the ticks are not 0 to 100, but 0 to 60. So we could do something like this. And then instead of printing our x ticks, we print our y ticks. And remember that the x values should not be scaled here. They should all be 0, right? So 0 for the x, and instead of these being at the bottom of the chart, they should be on the y value, scaled according to y scale. So we'll go ahead and write y scale of tick, which we'll see a bug because this has not been imported. So we'll go back into app.svelte and we'll pass, and well, we need to create the component first, and we'll pass this into our y-axis. Sorry, I couldn't type there for a second. And then we'll do the exact same import. Again, this is a lot of importing similar components. So axis y exists. We'll go ahead and pass height, and then we'll save. And there you start to see our ticks occur. So that was pretty quick. I'm trying to be sensitive to time, but basically what we've done is we've created the same type of file here, just one for the x, which is on the bottom, one for the y, which is on the left. Now we have the numbers that we need, but we don't have these reference lines that I think provide some nice little visual flair. So the question is, how do we do that? This is where the line element comes into play. And if you look here, we could just copy this directly from the reference. A line will take an x1, a y1, an x2, and a y2. So for our elements, we want, and let me save this to show you, you see the line occurs right there. We don't want these values, right? We want the scaled values for our y ticks. So we'll go ahead and pass the exact same values that are given to text. And already you start to see what it is that we were trying to produce. Now, x1 of 0 is in fact correct, but x2 of 100 is not. So what do we want instead of x2 of 100? Well, if you look at our chart, we want it to span the entire chart width. So, given what we already know about components, let's go ahead and pass width as a component or as a property into our axis y. Now that we have width, we can go ahead and pass it into the x2 like this. And now they span the entire chart width. So right now they're a bit ugly, they're just too strong, right? So let's just change the stroke. You can change this to whatever you want. You could do gray, or if that's still too dark, I like this color, this hex code of CE, CE, CE. And now they're a lot less visually obtrusive. You'll notice that these text elements are kind of too close to the lines. An easy way to fix that is to use another attribute called dy, which can be thought of as kind of a nudge. And we could just move them up, say 6 pixels. And now they'll move up. So that's basically what we want here. Now, I think we have the main components that we want for our peripheral elements. But you'll see that there's this weird overlapping and there's these issues. It's kind of ugly. The points are almost spilling into the axes. What we need to do is add margin. So that is the next thing that we'll go over, is adding margin to our charts. And what we mean by margin is this graphic from Amelia Wattenberger, I think, illustrates this really well. But you can think of your entire chart as having one singular wrapper. And then within that, you have margins, which is where your peripheral elements live. And then bounds, which are only the data points themselves. So that's what we want to create, right? Is a chart with margins and then the inner chart. And if we go back over here, we can do that in app.svelte since we want to access it in multiple places. And we can say the margin, and this is just a placeholder, we can change it later, will be an object with the following properties. Top of 20, right of 20, left of 0, and bottom of 20. So if I save that, nothing will change yet because we need to account for it in these other places. So let's pass margin as a property into both our axis x and our axis y. And again, in order to accept it, we'll write export let margin, and we'll copy that into axis y as well. Now what we want to do is move our axes according to the margin. Because if you remember from this graphic, you can see that the axis y, for example, begins right before the chart does. So it needs to account for where margin left starts. Same with the bottom margin, that's where we want our x-axis to live. So after importing margin into our x-axis, what do we want to do with it? Well, quite simply, we want to move each tick to occupy the space given to it in the bottom margin. So instead of pushing all of these elements down by 400 pixels, we want to push them down by 400 minus whatever space we have allotted for the margin bottom. So if I go ahead and type height minus margin bottom, you'll see those move up. And there's still an issue here, which we'll get into later, but this is what we want to do for now, is move the ticks according to margin bottom. Let's go into axis Y and account for the same thing. And we could do this one of two ways. We could do it with the Y value, or we could add a translation to the entire group. So with Y, I'll do that. I'll say transform, and this is some more syntax that'll be helpful as you get into data viz. We're going to transform translate, mean move everything according to margin left, which is how we want to move it horizontally, and then margin top, which is how we want to move it vertically. Now if we save that, you'll see that these actually shifted down. And now you can see the top value here, which you couldn't see before, right? So we're already starting to see how we can use margin in order to show visual elements, and we're making great progress on that front. Now you'll notice that these values are still not visible, these circle values. So what we need to do is account for the margin also in our inner chart. Because if you look at this visual, right, these are no longer spanning the entire chart width, the entire chart height, for us 400 by 400, they're occupying this smaller bound that accounts for the margin. So if we go back in here, the way that we'll change that is actually in our X and Y scale. So instead of 0 to width, we want the X scale to return values between 0 and width minus the horizontal margin values. Now you'll notice that it does in fact shrink. We'll do the same thing with height, and we'll add margin top and margin bottom as the things that we want to account for, and you'll notice that it shrinks. All of a sudden, we're starting to see exactly the kind of relationships or the type of tweaks that we wanted to see, and it's looking a lot closer to this chart that we're working toward. So now that we have accounted for the margin in our scales, we can also account for it in where the circles are actually rendered. So you'll remember that each of these circles are rendered here, but again, we need to translate the entire group by the margins. So what does that mean, right? Essentially, we need to wrap our chart circles, let's just call it circles, into a new group, and we'll translate, meaning we'll move that group according to the margin left and margin top. So I'll write transform, translate, margin left, margin top, and we'll close that. Then you'll see that the circles shift to the left and down. Because margin left was 0, they actually don't shift to the left, but they do in fact shift down, and now they're fully visible. So we're making really good progress here. I think the last thing that we need is a bit of a tweak on our x-axis, because currently they're hanging above this line, and we want them below. So there are a few ways to do that. We could push it down using dy, like dy of 10, it would go down, or we could add this property called dominant baseline, which is kind of vertical alignment. We could say hanging. It's up to you what you want to do. I'll do this, and then I'll add a dy of maybe 6, and now they're under the chart. Finally, maybe we add percentages so that it's clear. And then this 100 is currently not visible, so there are a few ways to fix that. We could add more right margin, something like that, or we can make all of the fonts smaller, or we can make the text anchor, which is like the horizontal alignment, something like middle instead of start. There are a lot of ways to fix this. For now, what I'll do is I'll just add more right margin. This is a kind of imperfect fix for the sake of time. And now you can read all of the labels. Finally, for the sake of time, I want to kind of move on. So I think we're going to skip the axis title here, but I will add an axis title up here to show hours studied. So within axis Y, you'll see that we have each of these ticks rendered. And if I wanted, I could type something like hours studied, and they would all appear. That's obviously pretty ugly. We don't want all of them to say hours studied. We only want the top one. And the way that we do that is with what JavaScript calls a ternary operator. So essentially, a ternary operator will evaluate what's on the left side And if it's true, it will return what's on the right side. Now, how do we actually explain that? So if tick equals 60, let's print hours studied. If it does not equal 60, let's print nothing. That is the logic here. If true, then print this. If not, then print this. Let's click save. We can already start to see that working. And you could do that with many other things. For example, we could only render the percent on the 100, or we could change the appearance of this bottom line, for example. So if tick equals 0, then let's make it black. Otherwise, let's make it this faint gray. Let's close that, and now you see that's a darker color. So that ternary operator can be very, very helpful as well. Okay, so we've added peripheral elements. Let's move on to our third step, which is going to be responsiveness. Now I know you're thinking, wow, peripheral elements are really hard, because they are, and it can be really annoying to remember how margin works. So don't worry, it only gets better from here. It only gets more exciting. And responsiveness is a really easy thing to do in Svelte. What we'll do is we'll update our existing width variable to track the container width, rather than some fixed number like 400. And the way that we do that is with Svelte's dimension bindings. So here's an example of dimension bindings where if you pay attention to this and the numbers above it, you'll see that those numbers increase as we increase and decrease as we decrease. Essentially, we're keeping track of the width and height of this element, right? So what we want to do is do the exact same thing, but track our chart container and then update the width according to that. Okay, so basically, outside of our SVG, we'll need a new div, and we could call this whatever. Let's call it chart container. And we'll write exactly the syntax that you saw here. Bind client width and assign it to a certain value. This is a pattern that you'll use in a lot of charts, so I would pay attention to this. Bind client width, and we'll assign it to width, which we already have defined up here, right? Then we close that div, and we close it out here too, and we click save. And already you see that our grid lines are going all the way to the end of the chart now. That's because width is now updating according to the screen. So we already almost have responsiveness figured out, okay? The only thing that's not fixed are these circles, because these circles are staying at their initial X scale position, because that is a constant that we define at the very beginning and then we never update. So we don't want that. We actually want to update X scale whenever width changes. And in order to do that, we'll use what's called a reactive declaration. So this is this funky syntax that's a dollar label. It has a dollar sign and then a colon. And basically it says anytime something that equals on the right side changes, update the left side as well. So if I click, you'll see this number consistently updates because it's tracking changes in its right side. So instead of X scale being defined once, we want to update X scale anytime width changes. And it's as easy as changing const to $:. We click save, and our chart is now responsive. So like I said, responsiveness in Svelte is one of the easiest parts about Svelte. It's one of the most exciting parts because those who do data visualization know that responsiveness is a huge pain to work with. But with basically 2 lines of code, we've already made our chart responsive. We can move on to step 4. So our fourth and final step for today's chart is adding interactivity. In our final chart, you'll notice that if we hover over something, there's a tooltip and the tooltip moves. And also if we use our tab key, so I'm using my tab right now, I'm using my keyboard, it will also focus and show data for those individuals. And if we hover off, that tooltip disappears. So how do we do that in Svelte? We want to render a tooltip whenever a user hovers over a point. And so we'll create a new variable and call it hovered data that will update whenever someone mouse overs or hovers over a circle. So let's go ahead and create this new variable and call it hovered data. Now at first, if I console log hovered data, it's going to be undefined, right? Because it doesn't exist. I just said, let it exist. And what we want to do is say on mouse over of a circle. So you literally write on colon in the event you want to listen for. Let's set hovered data to equal, and remember this is the object that we're dealing with, to equal student. Let's save that, and then watch as I hover over circles. Now we can start to see the data for those individuals as I hover over them. let's say that I want to delete that or get rid of it if and when I leave the entire chart. So I can say on mouse leave, set hovered data back equal to null or undefined or anything else. Now I see Roy's data point, I see Jennifer's data point. If I hover off, it's back to null, okay? So what we want to do now that we have this tracking of the object for the hovered data, for the hovered student, is we want to dynamically render a tooltip if and when hovered data exists. So we'll use what Svelte calls an if block, which basically says if this condition is true, render this markup in your app. So if we copy this as an example, or you can write it directly, and we say if 1 equals 1, print a p tag that says hello, okay? We scroll down, we see hello, because 1 does equal 1. There's your math lesson for the day. If 1 equals 2 is not true, so hello will in fact disappear. That's how an if block works. In our case, we want to say if hovered data exists, then print something. So for now, you'll see hello does exist, but if I hover off, it disappears, right? So we see hello, goodbye. So we don't want to print hello, we want to print a tooltip. And to do so, we'll create a new component and we'll call it tooltip.svelte. And we'll import it on the same lines right here. So import tooltip from components/tooltip.svelte. And then we'll go within our components folder and create a new file called tooltip.svelte. Now, just to show that this is in fact working, let's print this and say hello from tooltip and close it. Now if I go here and I close tooltip, oh my bad, click save, hello from tooltip does in fact render, but it's rendering from the component, right? Again, we don't want to print hello from tooltip. We want to print the hovered data or the hovered student's information. So let's pass this as a prop into our tooltip and call it data within the tooltip. We accept it here by saying export let data, and then we can access it within our markup. So data by default is going to be an object, so this will be unhelpful. You'll see it's an object, but we could do data.student and save that. And now we can see, data.name, that is what we're calling them. And we can see Roy, Jennifer, Marshall, Krishna, Justin, Johan, etc. We can see the names of each individual. We could also render their hours studied very easily using the same syntax. So we made a tooltip, although it's at the bottom and it's very ugly and it's not following our hover event. So how do we fix that? Essentially, we want to position this tooltip absolutely within our chart. Now, what does that mean? If you're not super familiar with CSS, we essentially need to use what's called absolute positioning. So an element with position absolute is positioned relative to the nearest. This is not going to help you. Let me explain it in simpler terms. Essentially, if you provide a position absolute, you'll provide a left value, a top value, a right value, a bottom value, and it will basically move to wherever you've positioned it using those top, left, bottom, right values. So for example, this div has element position absolute, and you'll see that it's kind of at this midpoint because the person positioned it 80 pixels down and on the very right side of the screen. So that's how absolute positioning works. And we want to position our tooltip absolutely according to the hovered event. So remember that we actually have the X and Y values of these circles accessible from our app.svelte because you'll recall that we changed the CX and CY to basically be the X scale and the Y scale of student.grade and student.hours. So we just want to access that information in our tooltip as well. Let's go ahead and pass X scale and pass Y scale into our tooltip. We'll accept those. And then what we can do is, just to verify this is working, let's console log the X scale of data.grade. And so anytime I hover over something, you'll see 40.6, 81.2, 121.8, here at the very right side, 401. That's what we expect. So we're actually seeing the X positions of each of these. We could do the exact same thing for the Y positions. So let's place this entire tooltip in a new div, call it tooltip, and we'll add the style of position absolute as we just described, but then we say the top should be equal to the Y scale of data.hours, and the left should be equal to the X scale of data.grade. Let's close that div over here and hover. And I think I probably did something incorrectly because it's not rendering as I expected. One thing we can do is we can replace this with this syntax instead, and then we can render it like this. Oh, I need a pixels value. So the issue here was that, it's printing the number, but it needs to have the pixels, I believe. Yeah, and so now you'll see, sorry about that, you'll see that because we position these with their pixel values, they do in fact track our mouse position. And already we have a tooltip that's working, it's just ugly. So how do we fix that? What we need to do is add some styling. So you'll remember that our style tag is where we put CSS rules. So I'll open and close style, and then I'll say, here's some styles for our tooltip. Let's just say it has some padding of 0.5 rem, or maybe you could say 6 pixels. It has a background of white, and it has a border of 1px solid, let's do a light black, like so, or you could call it whatever you want. Now if I hover, you start to see this tooltip moves, or it has good styling. One thing is, if I hover over a circle now that's covered by a tooltip, it's not gonna hover, and that's because I'm actually hovering over the tooltip itself. So we can add this nice little rule called pointer events none, and now it's not registering that as an element, so I can actually hover over new points, and it will in fact follow. Next thing is that it looks kind of jittery. It just transitions from one point to another immediately. We can add this nice transition using CSS properties, like so. And now it will update using, in 300 milliseconds, it will transition the top and left properties, like so. So we already have this smooth transition using just one line of code. Now, obviously, I think you'd want to change this up a little bit. You might want it to be a little bit prettier. So let's just say we have 2 p tags, and we label this hours studied, and then we look at it again, and it looks a little bit better. And then maybe we say, this is not a p tag, and this is all personal preference, right? We just say this is an h1, and the h1 should be slightly darker. It should have a font weight of 700, and it should have a little bit of margin under it. So it's 0.25 rem. There we go. We have something like that. So on a high level, we've just solved the tooltip problem. There's some additional things that we could do. Like if you look in our final chart, you'll notice that if I hover over this side from the chart, you'll see that it offsets to the left rather than the right. And we don't have that in our current chart. If I hover over here, it'll create this awkward little consolidation. That's reserved for maybe another lesson. Just for the sake of time, we'll skip out on that. But it's pretty fun how we solve that problem as well. As you can see, it adds a little bit more complexity in this final chart, as you can see here. But let's spend the next 3 to 4 minutes just finishing up the interactivity section. And then that'll be the final part of our chart, right? So for now, the tooltip will remain kind of ugly. It's not a huge deal. You can style it on your own if you want, but the pattern that we've put down here is positioning absolutely and then transitioning between points and having it disappear if and when an element or the user leaves the chart. So the last thing that we should do is say, if a user is hovering over a given circle, let's make that visually clear to them. Right now, it's like, is this in reference to this point or the next point? It can be unclear, but we could transition the circle's styling to look specific to that circle that's being hovered. So what does that mean? Let's say in our circle attributes, we have all of these CX, CY, R, fill, stroke, etc. Let's say that we change these if and when hovered data exists and is equal to that student, okay? So let's just start off with the radius as the easy one. We'll say if hovered data exists And if hover data is equal to student, then let's actually make the radius 20. And then otherwise, let's make it 10. So here I'm saying if this is true and this is true, and then I'm using the ternary operator to say return this, and if false, return this. So I save it, I hover over a point, you notice it gets bigger. Let's do the exact same thing for our for opacity, which we don't yet have yet. So let's create a new attribute and call it opacity, which is essentially the alpha or the opacity, the transparency of an element. And let's say if this is true, then the opacity is 1. Otherwise, let's make it 0.3. So now you'll notice all of these become transparent. That's actually not what we want. What we want to say is if hover data exists, then do this, right? Then do this entire ternary operator. But if hover data does not exist, just make all of them 1. So now you'll notice that they're all 1. If I hover over 1, then all of them fade except the hovered circle, right? So we actually have already finished these kind of like dynamic circle styling, but it looks ugly because they're so abrupt. So let's add a style and say for every circle in our chart, let's transition all of the elements by 300 milliseconds. And then let's end the style right after. And now let's try to hover. Now you notice everything is much smoother. Notice how between it looks smooth, the circle's radius increases, etc. We can also add a cursor pointer because that's usually used in web development to illustrate some hover event. And we now have hover events that are made visually clear to the user what we are keeping track of. So that's basically it for interactivity. The last thing we want to do is make sure that this is accessible for keyboard users. So right now, if I click tab, nothing happens. That is how you would expect to navigate through this chart. But for those who use keyboards, we want to mimic the mouse over event using tab events. So the way that we'll do that is we'll add an on focus event. And we'll actually make the on focus event identical to the mouse over. So it'll just copy this code directly. And then you'll notice that we still can't do it because these elements are not focusable. The way that you'll make it focusable is by adding a tab index of 0. This is a kind of like accessibility thing if you want to do some research. Tab index of 0 means that the element should be focusable in sequential keyboard navigation. Okay, so now that it has a tab index, it is in fact focusable. We click save and we click tab. You'll notice it does in fact go from user to user, from student to student. Now it adds this outline right now, which we don't really need. So you could do this rule, circle, focus, outline of none. And generally that's a bad accessibility practice, but because we have other visual cues, like the fading of all other circles, you don't really need the outline in this case. The last thing you'll notice is that all these circles are kind of randomly sorted, and we probably want to go from the left to the right. So the way that we could do that is we could actually sort our data in the each loop. This might be complex, but just for the sake of completion, we can say sort according to grade, which I believe would be like so. Now if I tab, you'll notice it does in fact go in order according to the grades of each student. So I believe we finished interactivity for today. You know, we have circle hover events, we have nice styling and cursors that represent those hovers, and for keyboard users we have an identical experience where they can tab between elements to see who is in fact being hovered. Maybe the final thing that we'll do here is we'll add a chart title because right now it feels pretty barren without it. So let's just add an H1 and say study longer, score better, or whatever you want to make your chart title. This is up to you. You save it and you notice that it's currently kind of stylistically out of sync. So let's just add an H1 style and say the font size is, you can choose this, but we could say 1.5 rem, the font weight could be 600, and the margin bottom, so that it has some room to breathe, could be 0.5 rem. Save that, now we have a chart title that works. So in summary, we've built together a chart that is responsive, and instead of actually, maybe while we are here, notice how they lag. That's because we have a transition of all. So let's actually make the transition specific to radius and to opacity. So now we still see these hover events where the transition occurs, but if we resize, it's immediate, it's not laggy. I think that's a little bit better. So with that being said, we have a chart that is fully responsive, that has these peripheral elements, and that has interactivity, both for users who use a mouse and for keyboard users. So there's a lot more that we still could do. Again, this is a bare bones implementation of this first chart, which is slightly nicer. It has some more styling, it has some more handling, it just feels a little bit better. And this was meant to be kind of an introduction to a lot of the patterns. So I hope that this, working through this together, was a good introduction to those patterns. And if you are interested in learning more, like I talked about at the beginning, this is kind of a preview of the course that I'll be writing over the next month or so and finally publishing by this end of this year. We worked on a simple scatter plot today, but we're also going to be building a bee swarm chart together in this course, a rotating globe in this course, and a New York Times style scrolly telling article. So there's a lot more to get into that you can look forward to if you register for my course and if you take it when it does come out. So I hope that you will do that if you have any further interest in this, and I hope that this kind of whet your appetite towards this. So Cheryl has asked if this sandbox is able to be shared. Yeah, 100%. So I'll share kind of the polished final version. See if you can access this. That is too long. I'll send it to Newline and see if they can. There we go, okay. So I'll send this. Thank you, Giuseppe, for saying good presentation. I really appreciate that. So hopefully this works. This is the polished version. And if you want the final version, or the version that we worked on today, that would be here. And then you can access it there as well. So yeah, definitely feel free to ask any questions in the chat. This formally concludes kind of the presentation part of this. So it was awesome to do this presentation for y'all. If you have any questions, you can reach out to me on Twitter. It's at CL Rothchild, and I would love to answer any questions and be as helpful as I can. Thank you all for the kind words. It really means a lot. I really enjoy data visualization. I really enjoy Svelte, so super happy to have hosted this workshop with y'all. Well, thank you so much. And if there are any other questions, feel free to drop them in the chat or reach out to me on Twitter. But if not, I think that will conclude this workshop. So thank you all so much. I hope you all have a